So welcome back. So use contour integration to calculate the real integral 0 to pi of this function. So what we have to do is to first observe that the given integral can be written in the form. So note that f of theta sine theta, i.e. the integrand here, is an even function. So integral from 0 to pi of 1 plus cosine of 2 cosine of theta (5 plus 4 cosine of theta, the theta, is simply a half of the integral from 0 to 2 pi 1 plus 2 cosine of theta over 5 plus 4 cos of theta, the theta. Because the transformations we are going to do to the integrand dictates that the limits will be from 0 to 2 pi. And since this is an even function, then we can always have this relationship. Now, so we concentrate on this integral here. So say I is the same as real okay, let me just write the same thing. So let's call this this integral, let's give it a letter I. So let this call it I. So because the problem was to find real integral, then we can say this is the same as the real part of the integral I have from 0 to 2 pi 1 plus 2 cos theta 5 plus 4 cos theta the theta. That is according to the question, because they want us to find the real part of that integral. So this is the same as saying real part of 1 over 2, 0 to 2 pi, and then we write this one as 1 plus 2, then I can say cosine. Actually, I need to put at this point here, because now I've introduced the aspect of real part of, then this will be a general, so 2 into cos of theta plus I sin theta. So immediately I write this one in general form, then is when I introduce the term real part of. So cosine of theta plus I sin theta is the same as e raised power I theta. So then we write this one as 1 plus 2 e raised power theta I divided by 5 plus 4 cosine of theta d theta. Remember, e raised power theta I, this soil identity, is cos of theta plus I sine of theta. Now with that, we'll have next, let z e raised power I theta, the theta is dz over iz, can always be shown, and cosine of theta is the same as a half into z plus 1 over z. So I will now be the real part of a half. Now integral now along C, where C is a unit circle, 1 plus 2z divided by 5 plus 4 over 2 z plus 1 over z, then dz over iz. I'm simply replacing the theta by dz over iz. So this will give us I equals to the real part of a half integral along C. So remember, specify that C is a unit circle. So we'll have 1 plus 2z. Now this is the same as 5 plus, I multiply this one by 2, so we'll have 2z plus 2 over z, and then multiply by iz dz. So I will be the real part of a half integral. I can multiply both numerator and denominator by conjugate of this one. So I'll say minus I into 1 plus 2z. And then, so this will be 5z plus 2z squared plus 2, because now z times over z, i.e. I is real part of a half integral along C of negative I 2z plus 1 divided by 2z squared, and then plus 5z plus 2 dz. Yes, dz here. Now, this is a quadratic, so product is 4, sum is 5. So numbers 1 and 4. So 2z squared plus z plus 4z plus 2. So common here is z into 2z plus 1 plus 2 into 2z plus 1. So z plus 2, 2z plus 1. So which means that I can be written as real part of the integral I have, integral along C, negative I 2z plus 1. And then this can be written as 2z plus 1, and then z plus 2 dz. So you see, by doing this, some terms will cancel out. This term cancels out. So we'll have I is real part of, so I factor out negative I over 2 integral along C of 1 over z plus 2 dz. And actually the pole, so the pole is z plus 2 equals to 0, i.e. z equals to minus 2. Since there is no pole within the unit circle, then f of z is analytic in C. And this circle, by Cauchy theorem, integral of any function f of z dz along any curve C is always 0 if f of z is analytic in C. Hence, this implies that a residue at that given point is 0. Therefore, I, which is equals to a real part of negative I over 2 integral along C of dz over z plus 2 is equals to 0. Hence, the given integral is equals to 0. So that is how we argue out the solution for that given problem. Thank you.